Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 3rd. Looking at significant wave heights for the South Pacific Ocean, we see a clearly defined gale producing seas pushing 38 feet in the central South Pacific Ocean, aimed well to the northeast. This is the focus of our attention and has been for the past day or two and will continue to be for another 24 hours. The short of it, swell is being generated and radiating north. Let's get into the details. So as usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough, and here is one, right here. Though, by looking at the wind speeds, you'd think it would not be that much of a producer, but it has done, actually, quite well. Winds here, in pockets, only to 100 knots, lifting to the northeast, but what that does is help set up a clockwise circulation in the southern hemisphere. Clockwise circulation is the indicator for low pressure, and of course, low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, produce swell, and swell, when it hits your beach, of course, makes surf. So, we have a trough in play, and it is to continue into Sunday evening, into Monday, and slowly easing off to the east, then fading Monday night, and then pretty much gone, and you start seeing this zonal flow setting up. That is, the southern branch of the jet here is forecast to build under New Zealand, push off to the east. You already see the start of energy here also building. That will probably cut off any gale activity for a while, and there you go. You see it actually a ridge pushing south. Now here is a little bit of a trough forecast to develop Wednesday night. Good area winds there, 140 knot winds pushing up to the northeast, but not reaching very far to the north, and the ice line is somewhere down here. We'll have to go look. I don't recall right off the top of my head. Basically, it's a zonal flow here, and that trough just doesn't materialize, doesn't push off well to the north. And as we get into the weekend, no real clear support for gale development. If anything, a ridge pushing south here. That only helps promote high pressure down at the surface. We'll roll this out. You can see as we get 180 hours out, maybe a bit of a trough forecast. Hard to tell. Week out, never believe the models, but maybe some hope. We'll see. Next up, we take a look at surface level wind, surface level pressure, and as can clearly be identified, winds here 45, almost 50 knots, pushing due northeast, associated with our low pressure system that's in the trough in the central South Pacific right now, 12Z Sunday. That's the model run. These winds actually have been in play for 2 days. In fact, we can go back and look at the pattern for this storm. And here we go. We're going back, looking back to Thursday, 18Z starting. A little bit of a low pressure here developed southeast of New Zealand. Started building. Notice there was already wind in this area associated with another low, and that sort of roughed up the ocean surface. So as this next low starts moving and building fetch over the same waters, there was already basically speed bumps in place for the wind to get traction on, and had something to catch and started building seas easier and quicker. Anyway, as we got into Friday morning, good area, 45 knot winds pushing to the north, building to 50 knots by 18Z, back to 45 knots in the evening, lifting north, and then a secondary fetch developed on Saturday with 45 knot winds, pushing 50 knots again, 18Z on Saturday, then a broad area, 40 to 45 knots as we got into Saturday evening and into Sunday morning, and there you are as of right now. Let's go take a look at the forecast. And then moving forward, and the new model just posted, so we lose, oh, there we go. There's our 6 hour, 18Z. You see winds down to, what is that, 40 knots, and turning more to the southwest to almost west. The gale starts falling apart Sunday night as we get into Monday. Just a remnant of it, and that's it. And now we know the jet is another little trough, I'll call it a proto-trough, develops under New Zealand on Wednesday, but you see winds just never really getting traction, 35, maybe 40 knots, but look at this, a lot of fetch aimed to the south, only 35 knot fetch aimed to the northeast, still over a pretty good area, but you really need minimum 40 knot winds to get a long enough period to be able, for the resulting swell to be able to survive the journey north to California and Hawaii without experiencing significant decay. And so basically 35-knot winds. Even over a broad area, it looks impressive, but not probably strong enough. Then we're out into Saturday of next week. This cutoff low develops here again, 40-knot winds. In fact, let's go back and take a look. Yeah, that's certainly good for Tahiti, perhaps, but probably not big enough or long enough to do a whole lot for the U.S. West Coast. And there we are, 180 hours out. So, the short of it is the system that is in developing or in flight right now in the South Central Pacific, that is going to be the focus of attention for the next week. All right, so let's go see what effect those winds had on the ocean surface. And we're going back. 06Z Friday, June 1st, our little system started developing here in the Southwest Pacific, quickly building 30-foot seas or 31-foot seas. 12Z Friday, ballooned up to 36.9-foot seas. We'll just call it 36 feet. Lifting, but notice the track, pretty well to the northeast. There you go, and that's what you want. That really helps direct energy in, whichever direction the storm is moving. If it was going west to east or gale in this case, then all the energy would be going in this direction, but because it's lifting north, that pushes energy much better off to the northern hemisphere in particular. Anyway, get into Saturday, you see it starts fading, 37-foot seas, but then that secondary fetch starts developing behind on Saturday evening, and 06Z Saturday, there we go, 36-foot seas, 38-foot seas, we'll call that 37 feet, 12Z Sunday, oops. And then here we are, the forecast model. That was all hindcast data we were looking at. Now, significant wave heights, sea heights, 38 feet in one tiny little area, 12Z Sunday. Building supposedly to 40 feet over a small area. That's already happened as of 18Z Sunday. We're looking to see if the JSON-2 satellite can make a pass over there and record something. But this, we'll go back here. We'll just tell you, it made a pass right over this area. It said, 32-foot seas. Right, it passed right over here, and one measurement up to about 36 feet, and that was the only pass over this system. So, but basically, it confirmed what the models were saying. Anyway, so into Sunday evening, still a good solid area, 38, 39-foot seas, and then fading from there. So basically, a two-pulse system over a good number of days. That should set up a good long run, multi-day swell event into California, sideband energy into Hawaii. In fact, let's go back and just take a look right here. So where is that? There we go. Hawaii is about 158, 155. This due south of the island. This would be a straight south swell for Hawaii. Most of the energy, though, pushing off east of there. Much better relative to California. Unshadowed by Tahiti. So good for a couple of days of swell for sure. Anyway, looking beyond then the next system. This is the one that tracks real far south. And here we go. Here's the ice line building to the north as winter starts setting in the Antarctic. What's that? It's down in 65, maybe 66 south, something like that. And you see the system right on the edge of the ice line, just not getting a whole lot of traction. 30, 32-foot seas, certainly good for, there we go. But notice it's kind of falling southeast here. It's up here, the peak of, or the core of the highest seas tracking down like that. Watch this. See that? So probably from this system, if it even forms, very limited sideband swell relative to mainly California and just not looking particularly good. Another system does the same thing, but it's falling southeast too. Probably not a whole lot from that. And then we're a week out. So right now, the system that's in the Central South Pacific, again, appears to be the main source of swell, at least, for the next week. No other swell production sources are indicated. And it takes about a week for swell to radiate from that position in the Central South Pacific up into California. A little bit less relative to Hawaii, let's say 5 days, something like that. So you can kind of do the math and figure out when it's going to hit your break. In the meantime, wind swell is the most likely swell source. Taking a look, you see surface level pressure charts for the Northeast Pacific. High pressure, 1032 millibars locked. What is that? About, what was that? 1. So each one of these guys, about 3, 6, 9, yeah, about 1,000 nautical miles northeast of Hawaii. And off the California coast, a good bit, 1,200 miles or so. Just eyeballing it. Anyway, that high pressure getting ready to start ridging into this area here, generating north winds along the California coast. There's wind swell in the shoulder, head high range, something like that in Northern California right now, probably down in Central California. Bit of an eddy flow in effect right now, that to be short-lived. Also east trades over a rather shallow area, pushing into the Hawaiian Islands, good for even shorter period wind swell. You see as we get into Monday, trades sort of build in coverage, a little bit more consistent relative to Hawaii, helping to increase wind swell. Fetch relative to California falls south, and so it's better when the fetch, at least relative to Central California, if the fetch is up here, to have the fetch area directly over your beach, not so much. Relative to Southern Californian wind swell, though, if the fetch is down over Central California, that is a bit better. But notice low pressure tracking to the Gulf of Alaska here. Not enough to generate any seas of interest, nothing to really get you excited. But that at some point will cut the legs out of the gradient some, and that's kind of what's pushing it south. You can see the low pressure continues as we get into Tuesday, Wednesday. The high fades, trades falter some relative to Hawaii. Wind swell fades out. The gradient fades out relative to California. As we get into Thursday, more of the same. This continued low pressure pattern. So the high pressure, see it very far to the south here. Low pressure controlling the northern Gulf of Alaska. The fetch continues along the California coast. So basically, you're just looking at this, you just get a lot of wind, really ugly conditions for the most part along California. Yeah, there'll be wind swell, but nothing great. Trades, because the high is so far south, the trades are mainly south of the Hawaiian Islands, not a whole lot in terms of wind swell there. Then as we get into the weekend, you see maybe the high will lift a little bit to the north. Nope, north winds still continue, even as we get into Sunday along the north and central California coast, 20, maybe 25 knots. A little bit better fetch pushing into Hawaii as we get later into Sunday. And there you go. Then this is kind of the more normal. The low pressure pattern fades. The high lifts to the north. The gradient shifts north a little bit. California back in business, and Hawaii also with wind swell. So lots of wind swell in the forecast. Not so pretty, though, relative to California. And just a real quick look at the North Pacific, because on Friday, June 1st, a small system developed kind of unexpectedly over the North Dateline region. Seas built 22 feet up to 27 feet late Friday night, and 28 feet right over the North Dateline region. There's the dateline. This is the Aleutian Islands, so we just call this area the North Dateline region as compared to the Gulf of Alaska, or Northwest Gulf of Alaska. Give some relative positioning. Anyway, 28-foot seas may be good for a tiny pulse of swell pushing to the east into California and the Pacific Northwest. The deal is that with all the wind swell that's expected, you'll never even see that swell. Tiny energy maybe into Hawaii too. We're talking 2 or 3 feet at 12 or 13 seconds. So not a whole lot to expect from that. And that gets us to current time. And then we'll just take a real quick look here for the coming week to see what's going on. Remember, there was a whole series of low pressure systems moving through the Gulf, but they were weak. They didn't have much winds. You can see seas not even 18 feet associated with any of them. Theoretically, some tropical activity over here 5 days out, 6 days out. Don't believe that. Same thing off of Baja. Don't believe it. And there we go into here, a week out. Interesting part, if this tropical system does develop, the models suggest it recurving off to the northeast. That would be hard to believe, but something to keep an eye on. For the most part, we're considering the North Pacific to be asleep for now. All the focus is on the southern hemi. All right, let's take a look long term. What's going on with the Batten-Julian oscillation and with La Nina, or maybe El Nino? As usual, we like to look for signs of the active phase of the MJO. When in the active phase during summer months, typically there's not a strong correlation with what goes on down in the southern hemi, but in winter months, in the active phase of the MJO, it helps feed the jet stream, which in turn helps feed storm development, mainly over the North Dateline region into the Gulf of Alaska. Same deal for the southern hemi. When the active phase gets going, it'll start, when the active phase is in the West Pacific, it'll feed the New Zealand corridor, and as the active phase moves east across the equator, then the area south of it or north of it in winter months, that's where the focus of storm activity would be. Right now, we see winds. This is from the TAO buoy array, a series of buoys strung across the equator, mainly used for monitoring El Nino. We see winds, just looking at the arrows, strong out of the east, pretty typical this time of year, and pretty solid still over the Kelvin wave generation area. That's the area from 5 north to 5 south, 135 east out to about 170. When you have westerly anomalies in this area, then that helps create a Kelvin wave, so we call it the Kelvin wave generation area. Anyway, looking at anomalies, differences from normal for this time of year, we're looking for any signs of easterly arrows or westerly arrows. In the East Pacific, don't see it. In the Kelvin wave generation area, basically the same thing, kind of a neutral pattern. So basically, winds are normal for this time of year. No sign of the active or the inactive phase of the MJO. Looking at wind anomalies, now this is up at 850 millibars, up about 4,000 feet off the ocean surface, but it's a reasonable proxy for what's going on at the surface. Kelvin wave generation area, there's New Guinea, there's the dateline. The equator runs right along here. You can barely see it. There's South America. So the Kelvin wave generation area, draw a box right around in here and keep that in your mind. We see blues and easterly arrows. So this was back May 28th. Easterly anomalies. We go down here. Same thing. Easterly anomalies. Easterly anomalies. Inactive phase. That suggests the inactive phase of the MJO. And still continuing even on June 1st. So if anything, the model or the past history suggests some sort of weak inactive phase of the MJO is in control. Then we look at the forecast. This, okay, Kelvin wave generation area between these two tick marks. That's the date line running right down the middle of the chart. This is the whole planet on one chart. The blues are easterly anomalies. The yellows, oranges are westerly anomalies. So looking down through the Kelvin wave generation area, we see it looks like the inactive phase of the MJO started, let's say mid-May, and has been continuing the whole way through the month of May. Here's where the forecast begins. And where's our Kelvin wave generation area? Right there. Oh, you see a little bit of westerly anomalies trying to sneak into the West Pacific. But still, looks like the inactive phase of the MJO, if anything, is supposed to rebuild, filling the Kelvin wave generation area with, we'll call it modest easterly anomalies. So no real help from the MJO for the jet stream in the southern hemi. That said, we are in the inactive phase right now, and we have a gale, so the correlation is not always 100%, especially in the southern hemisphere. Sometimes it just sort of does what it does, and it's not nearly as tightly correlated with the MJO. In winter months, active phase of the MJO pretty much means you'll get some sort of storm cycle. Inactive phase means the storm cycle shuts down, but in the southern hemisphere, much looser correlation. So let's go look out 2 weeks. So this is outgoing long-wave radiation models. Basically, the blue suggests, so it's sunlight, these models depict sunlight reflectivity off the ocean surface. Blue means negative anomalies, means less sunlight reflectivity, means clouds, means the active phase of the MJO. So according to this, the statistical model, the active phase of the MJO is supposed to be building and supposed to hold in control for the next 2 weeks. Well, we know that's not really the case right now. The dynamic model has been the exact polar opposite. Now, this is also kind of an unbelievable scenario. It says the active phase is trying to get going, but within 3 to 4 days, a strong inactive signal is to show up, basically inactive phase of the MJO, and hold for the next 2 weeks. That's probably just as crazy as this scenario here. So hard to know exactly how this is going to play out. Phase diagram charts, assume you're looking down on this, assume the circle is, let's say, the North Pole. The MJO moves counterclockwise from west to east, from the Indian Ocean over the maritime continent, over the West Pacific, across the dateline, under the United States, across the Atlantic, back to the Indian Ocean. Round, round she goes. The heavy dot is where the active phase of the MJO is right now. So in the far east maritime continent, trying to make its way into the West Pacific. The further away from this circle the dot is, the stronger the MJO is, so it's pretty weak right now. Maybe forecast to build some, per this, the ECMF model, and move east for a couple of days. Each dot is a day, let's say 4 or 5 days, but then crash and fall apart and really never make it cohesively into the West Pacific. The GEFS model, GFS ensemble model, basically says the same thing, but not even making as much eastern headway as the ECMF. So active phase of the MJO, just really not expected to organize or do anything for the next 2 weeks per these models. The upper level model, there's New Guinea, so that's the West Pacific. There's the equator, South America there. Greens, so these are areas favorable for precipitation. Green is favorable, so that would suggest the active phase of the MJO, and it looks like it's supposed to make some east headway to about the date line on June 13th, and then pretty much just fall apart. No real inactive phase, maybe a weak inactive phase to follow, and then just descending into this completely neutral kind of pattern as we get later into June and early July. The CFS model going out a month, well, here we are right now. Again, Kelvin wave generation area between these two tick marks. The future to the bottom here, you can see we had a big active phase in May, and then in late April into early May, and then our inactive phase, the dotted contours started. Right now, we have supposedly little westerly anomalies, but that's again supposed to descend into easterly anomalies. The blues are easterly anomalies. Basically just kind of a muddled pattern until we get into maybe the later part of June when finally westerly anomalies start filling the Kelvin wave generation area. We know that eventually that's supposed to happen because we know La Nina is dying a quick death. But just because we think it's dead, purely from a textbook standpoint right now, it will take 3 months before it really fully becomes, noticeable in the atmosphere. And then finally, the 3-month CFS model, in this version, has the future forecast up here, working its way to the top of the page. Kelvin wave generation area, you see it right between these two tick marks, basically. So here's where we are, our little bit of westerly anomalies in the West Pacific, little bit of easterly anomalies over the date line, sort of this kind of easterly pattern going on till mid-June, and then you notice the yellows or westerly anomalies start building and continue solid through the end of the model run into the end of August. Let's overlay the MJO, see what it says. Here we go. So according to this, basically, the dotted contour is the inactive phase of the MJO, supposed to hold for maybe about another week, and then some sort of weak active phase starts building. Westerly anomalies set up, let's say the end of June, even mid-June maybe, and then it doesn't stop after that. The point being, these westerly anomalies should be feeding the jet stream both in the northern and southern hemisphere. As we get into the fall season, then we should be in pretty good shape. Looking at the low-pass filter, so the good news here, of course, is that the solid contours are what we call the El Nino bias or low pressure bias, fully in effect over the Kelvin wave generation area right now, filling it completely, and forecast, notice 1, 2 contours right now, supposedly building to 3 contours deep as we get into, let's say, mid-July, and hold the whole way into fall. That's good news. And the high pressure bias, this dotted contour that was in the Kelvin wave generation area in February, is completely out of it now and is going to be limited to just a very thin sliver, probably over the California coast in the early part of fall. And we expect that to even shift east as we get deeper into fall and winter. So what's the effect of all this on the ocean? Well, let's take a look at depth, sea surface temperatures. East Pacific here, West Pacific here. The X's are the sensors on the TAO buoy array strung across the equator. So that's where the raw data is coming from, and then they use a model. TAO uses a model to sort of fill in the gaps, because you don't have sensors everywhere. Anyway, and this is centigrade. 30 degrees centigrade water was limited to 155 east, and it's grown to 165 east. The 28 degree isotherm, which last week was about 159, is now holding steady, let's say at 160 west, and pretty deep, down about 75 meters. And the 24 degree isotherm is showing signs, so all this is showing signs of warm water moving off to the east. That's exactly what we want. That signals the demise of La Nina. The sooner, the better. Can't come soon enough. Anyway, water holding, what is that about? It's about 125 meters deep at 140, about 100 meters deep at 125 or so. and was about 30, maybe 35 meters deep up along the Ecuador coast. So not bad, no big change from last week. The differences from normal for this time of year. So we did see a large area of warm water off here, Kelvin wave developing. It is pushing off to the east. This is probably a little bit overstated. We think there's still more warmer water back here than what this TAO's model suggests. But what it does suggest is 4-degree anomalies basically south of California and south of Mexico right now, pushing off to the east. This means that this Kelvin wave, which it kind of stalled, it was working its way off to the east, and it kind of stalled for a couple of weeks, now appears to be moving off to the east. GODAS data, a higher res model using the same raw data, suggests, here you go, what do we got? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 4.5-degree anomalies right here at, let's say, 160 west. And you see the interesting part here, that's the last little bit of La Nina there, basically up along the Ecuador coast. It doesn't even count anymore. And even more interesting, see this, this is 0.5 to 1-degree anomalies hitting the surface now from, we'll say, 135 west to about 100 west. Keep those numbers in your mind. With much warm water below that, what we should be starting to see is warm water erupting on the surface. We've been waiting for this to happen, and it hasn't happened because the Kelvin wave kind of stalled. Right now, it looks like it is happening. When we get to the surface data analysis, hopefully we'll see some evidence of it. Then, of course, JSON-2 satellite data, strip out all the wind waves, strip out the swells, strip out the tides, and you see +5 to 10 centimeter anomalies above normal, meaning a bump on the surface, meaning warm water at depth, and now it has moved the whole way, here's the date line, continuously the whole way into Ecuador, over the Galapagos. All this means is that Kelvin wave is reaching the whole way from the date line now into South American coast, so we're just waiting to see if it erupts at the surface. And the same chart here, upper ocean heat anomalies, upper 300 meters of the ocean, West Pacific here, East Pacific here. We're going back in time. La Nina cool pool here in August, September, you get it, the whole way through. Then we had one small Kelvin wave push east and barely warm water in the January time frame, barely making it to the South American coast. Upwelling phase of the Kelvin wave cycle, and then here we had a big westerly wind burst in February, March. That started the Kelvin wave, but notice here it kind of stalled. Now, boom, on the move again, working its way towards Ecuador. So now, sea surface temperatures, see a little bit of cooling. This is pretty typical along Peru. Upwelling, south winds here, it always upwells. But it's not very large in coverage, not very strong. Warm anomalies just off the coast, and here's the big feature, right? This area here. So this image kind of doubles up. There's 100, there's 100, so there's some doubling. This dot is the same as that dot there. But we see 1, 2, 3 pockets of warming between, we said, what was it, 135, so that's about 100, somewhere right in there. So that's exactly what this looks like, is the Kelvin wave starting to erupt to the surface. And this warming has been here for a couple of weeks, but it's getting slowly. There's a very slow-moving train, but slow warming, building. The point being here, there's the last of the La Nina cool pool. It's now no longer on the equator, south of the equator, south of about, what we'll call that 4 south. So it's really almost not even in the official Nino monitoring range, and Nino 3.4 from 120 west out to about 170. So you can see what this means is as this area builds, sea surface temperatures in the Nino 3.4 region will build, and that will signify that once we get above 0, and we're tantalizingly close, we expect temperatures to start rising into the positive range in this area, and then in turn, the atmosphere will respond. You'll start seeing more precipitation here. That'll help rearrange the jet stream, and then all of a sudden, you're off and running towards what would be at least a normal pattern, if not maybe something more and better than normal as we get deeper into the fall. It'll take 3 months really, though, once we start seeing warming on the surface here for the jet stream to really pick up on it. So we're not talking till, mid-fall, something like that. Things would the the shift will happen in the atmosphere from a La Nina-dominated pattern to perhaps something more than just normal. Sea surface temperature trend for the past 7 days. Yeah, little pockets of random cooling around the Galapagos, random pockets of warming, but nothing, kind of a neutral pattern. But the reality is we expect to see warming building in this area, maybe starting a week out or so. And then here's the backed off view. Again, there's our warming happening right there. Not super significant, not like, oh my gosh, look at this. No, just a general warming, basically wiping out La Nina, but not doing anything more than that. There's a little cooling along Peru, and there's the last of La Nina right there. Consider it all but gone. We just want to see this build in coverage a little bit, get down to maybe five or so south, and chop off the last of this lingering little cooling right in this area, and then we'll be in business. Sea surface temperatures in the Niño 1.2 region. This is up along the coast of Peru and Galapagos. Not super significant, kind of noisy, but shows a general warming trend that happened March, April, kind of stabilized right now. The value today, minus 0.782, so 3/4 of a degree below normal right there. But we expect to see that to creep up slowly. And then in the official El Nino monitoring region, the Niño 3.4 region, again, same trend. Water temperatures heading slowly upwards. Today's value, 0.218. So just a hair shy of being normal. Just getting ready to push towards that way. We're maybe a week or two off from falling into a normal pattern is our guess. So what's the effect on the atmosphere? Two different ways of looking at that. And we're talking, how are the sea surface temperatures affecting the atmosphere above it? Positively or negatively. We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When the index is negative for, a month, that suggests the active phase of the MJO. Now, you can see here, it's been basically positive, suggesting the inactive phase of the MJO, but the past two readings are negative, so minus 15, but this is a rather noisy indicator. Take the 30-day average, and that tells you what's going on. The trend was negative, active phase of the MJO, moving to positive, but sort of backing off today. Today's value 2.15. So yeah, just kind of neutral, not even La Nina, not inactive phase of the MJO or active phase, just neutral. 90-day average, this gives you some indication when you look at it over time, whether it's El Nino, La Nina. It's been biased slightly positive, suggesting La Nina, and still holding there, 4.49. The atmosphere is a big boat. It's going to take a while to turn from La Nina bias to neutral or something else. The ESPI index, same as the Southern Oscillation Index, but instead of measuring the difference in pressure, it measures absolute precipitation anomalies, mainly in this area, right over top of where the cool pool was, the La Nina cool pool. The index today, falling again. This is not good, meaning drier here. It's minus 0.98. It was like up to minus 0.3 or 4, something like that. And now it's been falling the past couple of weeks. Hard to know why. Probably somewhat associated with the inactive phase of the MJO that's been in occurrence for the past 2 weeks. So again, the MJO affects this, and you have to sort of average this out long term to see. This is a 30-day rolling average, if you will. Okay, El Nino, La Nina would be more like a 90-day filter on this. So we think this is all attributable to the inactive phase of the MJO right now. Just real quick, looking back at the Southern Oscillation Index, just to put it in time frame, you see, or in perspective, here was our El Nino back in 2016. The index was negative. This is the 30-day moving average. Then here was our La Nina in late 2016 and 2017. Now notice it's sort of toggling back and forth, though more on the La Nina side than the El Nino side. There's 0 right there. We want to see this at least settle down into the neutral range. And then finally, the forecast for sea surface temperatures in the Niño 3.4 region, the official Niño monitoring region. So here we are. Let's see, April, May, June, and July. So somewhere right around now we should be neutral according to this model, and we're tantalizingly close to it. But the interesting part here, this model has gotten more aggressive now and suggests we should have half a degree to 0.6 of a degree above normal as we get to the beginning of July, and then creeping up to 1 degree above normal as we get into October, and holding, if not going to 1.1 degrees as we get into January. Now, this model has been the one that's been consistently biased on the cold side, and now it's saying, wow, El Nino conditions as we get into the fall and the winter. We still think that's probably a little bit on the aggressive side, but again, we like to remain pessimistic and not get too overhyped on anything until it actually develops. But and who's going to believe a model that goes out, 6 months or more? But still, this is a step in the right direction. All the data sort of says, and all the models are saying some sort of at least neutral, if not weak El Nino for this fall into winter. So this is probably not too far out of the realm of possibility. So the immediate good news, swell is being produced by a gale in the southern hemi right now. Decent sized seas, resulting swell size. It's not going to be anything over the the top. Minimum significant category probably for California, less for Hawaii because most of the energy is aimed east of there. But swell nonetheless, and piles of wind swell. So take that for what it's worth. Hope for better with the longer period swell coming from the southern hemi, and then long term beyond that. Again, our Kelvin wave continues to push east. Looks like it's starting to erupt weekly west of the Galapagos. We're expecting more from it. And the more it erupts and the warmer the water temperatures get, that will help wipe out the last vestiges of La Nina and set us up for at least a normal, if not better than normal, fall. Probably the later part of the fall was when we'll start seeing more storm activity and a return to a stronger North Pacific storm pattern. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.